All right, let's dive right in. We're going to break down the most fundamental properties of our universe. We're talking its shape, its absolutely mind-bending scale, and the mysterious ingredients that are holding the whole thing together.
And to really get us in the right mindset, let's start with this incredible quote from the one and only Carl Sagan. It just perfectly captures the all-encompassing, epic nature of what we're about to explore.
So here's our roadmap for today. We're going to start with the basics, just defining our terms. Then we'll get into the shape of everything and try, to wrap our heads around its staggering scale. After that, we'll look at its bizarre, mostly invisible recipe. And finally, we're diving into the deep end, asking one of the biggest questions out there. Is our universe the only one?
Okay, first things first, before we go any further, let's get our vocabulary straight. You've probably heard the words universe and cosmos thrown around, maybe even used them interchangeably, but there's actually a really subtle and important difference between them. So let's start with a big one, the universe. This is, it's everything. All of physical reality, all of space-time, all matter, all energy. Think of it as the complete list of ingredients. The term cosmos, on the other hand, is more about the order within those ingredients. It's the universe viewed as this complex, intricate, and harmonious system.
All right, let's move on to a really fundamental question. What is the actual shape of all of this? And I don't mean a sphere like a planet. The true geometry of space itself is being forged in an epic cosmic battle that's been raging since the Big Bang.
And the answer to that question, it all comes down to the delicate balance between two colossal, opposing forces that have been duking out for almost 14 billion years.
Yeah, it's basically a cosmic tug-of-war. In one corner, you have gravity. It's the force of everything trying to pull back together, to collapse in on itself. And in the other corner, you have kinetic energy, that incredible outward momentum from the Big Bang, pushing everything apart. The entire fate of the universe hangs on who wins.
So, depending on the winner, you get one of three outcomes. We measure this with a number called omega. If gravity is stronger, omega is greater than 1. That gives us a closed universe, shaped like a sphere, that will eventually collapse in on itself in a big crunch. If the expansion is stronger, omega is less than 1, and we get an open, saddle-shaped universe that just expands forever. But what if it's a tie?
Well, here's the kicker. All of our best measurements, especially from projects like the Planck satellite that map the oldest light in the cosmos, tell us that omega is 1. The two forces are in almost perfect balance. And what that means is, on the very largest scales, our universe has no curvature. It's flat.
So we know its shape. Now let's try to get a handle on its size and age. And I'm just going to warn you, these numbers are going to sound completely made up. They are absolutely staggering.
Let's start with time. From the very first moment of the Big Bang until right now, as you're listening to this, about 13.8 billion years have gone by. That's it. That's the entire history of everything. Now, you'd think that if the universe is 13.8 billion years old, then the farthest we could see would be 13.8 billion light years away, right? But it's not that simple, because space itself has been expanding the whole time. The things that sent out that ancient light are now way, way farther away. This gives us an observable bubble that's already 93 billion light years across. And here's the truly wild part. That massive 93 billion light year bubble, that's just the tiny patch we can see. The best estimates for the total universe suggest look at that number. It's so big it's practically meaningless. It's a powerful reminder that what we see is just a drop in an infinite ocean.
So, if the universe is this incomprehensibly vast, what's it actually made of? You'd probably guess stars, planets, gas, and dust. But the real answer is way stranger and way more mysterious than that. Take a look at the cosmic recipe for today. See that tiny little sliver? Less than 5%? That's atoms. That's everything we can see and touch. The rest, the vast majority, is made of two things we know almost nothing about. Dark matter, which is some kind of invisible stuff providing extra gravity, and dark energy, a mysterious force that's actually making the expansion of the universe speed up.
But if we rewind the clock way back to the early days, just 380,000 years after the Big Bang, the recipe was totally different. Back then, dark matter was king, and dark energy was barely even a factor. Our universe has been fundamentally changing its own ingredients for billions of years.
Just let that sink in for a second. Every person who's ever lived, every star in the sky, every single galaxy we've ever photographed, all of it is just a rounding error in the cosmic budget.
We are living on a tiny, tiny fraction of what's really out there.
Okay, so this bizarre cosmic recipe, combined with the fact that the universe has a finite age, it leads us to some really deep, almost philosophical questions about why our universe is the way it is and why we're even here to notice it.
Now, this might sound like a question a little kid would ask, but it is honestly one of the most profound observations in all of science. It's a famous puzzle called Olber's paradox, and the simple fact that the night sky is dark is actually proof that the universe had a beginning.
Seriously, think about it. If the universe was infinitely old and infinitely big, then no matter where you looked in the sky, your line of sight would eventually hit a star. The entire sky would be blazing with light, as bright as the surface of the sun. The darkness we see, that's the empty space where the light from the most distant stars just hasn't had enough time to reach us yet. The dark is the proof of the beginning.
And that leads to an even bigger puzzle. The fundamental constants of physics, the numbers that basically run the universe, seem to be balanced on an impossibly sharp knife's edge. If you changed any of these values by the tiniest fraction, stars wouldn't form, chemistry wouldn't work, and life as we know it would be completely impossible.
So what gives? How do you explain this unbelievable, seemingly miraculous fine-tuning? Was it just a fantastically lucky accident? Well, modern physics has a pretty wild hypothesis that completely turns this problem on its head.
Welcome to the idea of the multiverse. The theory goes that our universe isn't the only one. It's just one bubble in a vast, infinite cosmic foam of other universes. Each bubble pops into existence with its own random set of physical laws. Most of them are probably sterile, dead universes. But if you have an infinite number of them, it's pretty much inevitable that a few, just by pure chance, would have the right settings for life to emerge. And of course, that's where we'd find ourselves, because we couldn't exist anywhere else to ask the question in the first place.
And that's the thought I want to leave you with. The multiverse completely reframes our own existence. Maybe we're not a 1 in a trillion miracle. Maybe we're a statistical certainty. In an infinite ocean of possibilities, a universe perfectly tuned for us isn't just possible, it's absolutely inevitable.